what I found again very, very powerful is to feel this right and left sides in the brain. So I think it was from the beginning, and I use it quite often also in some other context. If I just feel my sit bones on the chair, or when you're standing, you feel your feet on the ground, and then, as Bonnie said, like the shifting of the weight become more subtle. So it's not like a big shifting to one sit bone, but it's like almost not visible to on the outside. I'm shifting a little bit on my left side, a little bit on my right side, and and to recognize that really there are these two sides all the way up to the hemispheres, and that this is this image of the hemispheres, which is a deep the how is it called, the deep
Sulcus.
sulcus, yes,
Fishes.
central sulcus, fissure.
Fisher, yeah.
So it's the deepest in the brain. It's separating the two hemispheres. So to realize that is really there is a left and a right side, and it belongs to the cells of the right side and the left hemisphere to the left side. And we can do this with a little bit of shifting. Like one side gets a bit heavier and the other lighter. And just staying with that for a moment. And connecting it to everything on the same side. And this is I'm repeating myself, but it also to myself, that the cells from the right, they don't go to the left, and from the left, they don't go to the right. They stay on the side. What's crossing at some point are some nerves are crossing in the brainstem, but the cells, they stay on the side. And then this sensation or this experience can be even more subtle in the spinal cord, because the spinal cord is much smaller, but it also has a left side and a right side. So also there you have this division in the neural tube. You have a right side of the neural tube and a left side of the neural tube, and they in the middle is the canal, the central canal with the fluid, and which opens up in the brain to the ventricles. And so, yeah, we're going a little bit with this weight shifting, and then we can move our hands to feel a difference between the front and the back. And there is another, this is a sulcus, I think. It's the parietal sulcus, I guess. And there it separates the front from the parietal. And again, there we can feel it all the way down into the spinal cord, where also there is this differentiation between the front of the spinal cord and the back of the spinal cord, which we have been exploring before as the sensory and the motor. So the sensory coming in the back and the motor going out in the front, and sometimes we have kind of made in some kind of swimming movement, but now we can make it even more subtle, that we have front of the spinal cord and the back of the spinal cord, and that continues all the way up into the brain. And the frontal part, this will become the hypothalamus and the pituitary, or part of the pituitary to be exact. And the back part becomes the thalamus, or to be more correct, the two thalami. And the fascinating thing is that the front of the spinal cord, or the front of the neural tube, it ends with the hypothalamus. And there is this membrane, the lamina terminalis, which is kind of the top of the neural tube. And the back part of the neural tube, the back of the spinal cord, is continuing to grow and to fold over the neural tube to become the cortex. And then in the cortex, we have these different lobes. But we have also a frontal part, we have a back part, and we have a very back part, which is the occipital lobe. And we have the lateral part, which are the temporal lobes. These are the basic lobes which are visible to in the models, in the brain models. So that is what is visible here on this brain model. And then you have some deeper lobes, but just to name them, the insular cortex and the singular cortex. But what interesting is, maybe if you open your eyes, if you have not, if you have closed them, and just look forward to the horizon. And if you, with this horizon, you go back, you kind of follow the optical nerve, and the optical nerve is going to cross just between this lamina terminalis and the hypothalamus. So it is this, the optical nerve is above the hypothalamus, but below the lamina terminalis, and then it continues to, after the crossing, it goes again, it parts again, so it's crossing, and then it goes to the sides, lateral again, and it goes to the thalamus. But it's just for the locating of on what level what we are talking about is below the eye level is the hypothalamus, and above the eye level is the thalamus. And here we can play a little bit with when we are moving our eyes above the horizon and we're moving our eyes below the horizon, and just notice how it changes your state. And that it's what Bonnie was saying about the looking into the ocean, looking to your feet, so how your inner state changes when your eyes are moving above the horizon and below the horizon, and how the hypothalamus, the pituitary is going with that. What sensation it creates if your thalamus go further back, and if your hypothalamus goes down, and the pituitary. So and how you relate this these centers, the thalamus and the hypothalamus. And maybe when you go below the horizon, it can be also the feeling of letting your eyes drop, closing your eyes. And when you go above the horizon, open your eyes. So it's also an inner state, the inner state which is changing. And so in what we explore with the movement patterns is that up to sitting, when a baby starts to sit, the attention of in the brain is in the midbrain, and that is when the eyes are a little bit below the horizon. So that is, it's not yet hypothalamus and thalamus, but it's a little bit below. And when I reach the horizon with my eyes, I get out of the midbrain because I get interested, or the baby gets interested in the space. And then it goes beyond the kinesphere. So it's just like a little cue maybe for your own understanding, that when you go with your eye below the horizon, your attention is much more to what is close to you, what's happening inside your body, what is close to your body, what you can touch, what you can, I mean, the hand-eye coordination, what's around you. While when you reach the horizon, your attention goes beyond what you can grasp or have directly access to, but it's at the same time, it opens another possibility in your brain to go into space and to reach for something which is not close to you. And so in any of these states, we can receive and let the hypothalamus receive that information, but we need this flow. We need this ability to flow from the back to the front and from the front to the back, to be able to not block out any information and not to block out a motor response. And then it is interesting movement of the sensory part of the spinal cord becoming the cortex and becoming bigger and bigger, but the main development which is opening in the forebrain is more refined motor functions, which also then, when you bring your eyes, when you below the horizon, so you make this kind of movement of the cortex folding over the neurotube, you come exactly to that space where there is the optimal eye-hand coordination. So for manipulating objects, you don't if you manipulate objects, you don't do it with the eyes on the horizon, and you don't touch around like that, but it's something where you close, your fine motor skills happen in that kinesphere, in this kinesthetic space in front of you. And then when your eyes come higher and you reach, you're more in the social space of relating, of seeking, of searching, bringing things towards you. So having fluidity in that, in your eyes, and the level of your eyes, means also having fluidity in your brain to access these different parts. I'll take just another few minutes to play with this micro adjustments of your head related to your eyes and related to your ancient forebrain and the modern forebrain, the frontal cortex, eyes hand coordination, and maybe also the tongue articulation related to the occipital somites and the spinal cord, in the cerebral spinal fluid, in the central canal, in the ventricles. And then whoever wants to come back, while you can continue to explore, to move, to write, to rest,